Ring is a sampler instrument whose sound generation is based on amplitude and ring modulation. Ring modulation, the most effective form of amplitude modulation, can be best explained by two sine wave generators, where one oscillator acts as a carrier and the other as a modulator. While amplitude modulation initially only means that the amplitude of the carrier is influenced by the modulator, we call it ring modulation when this modulator has no DC offset. That means an amplitude that has the same distance to zero in the positive and negative direction as the maximum. With the regularly and periodically occurring zero crossings, the modulator has full control over the carrier, whose originally frequencies then no longer audible. By the applied ring modulation, two frequencies will be received instead as a result. The original frequency minus the modulator frequency and the original frequency plus the modulator frequency. The higher the modulator frequency, the further apart those two appearing tones are in terms of their pitch. If you modulate the amplitude of an audio signal with a slow sine wave, for instance with an LFO, you get the typical tremolo effect. When the modulation frequency is increased and oscillates in the audible range, the ring modulation effect gradually occurs, in which the individual modulation oscillations are no longer perceptible, but the sound spectrum of the carrier changes and harmonic and inharmonic partials are added. The sound characteristics are often perceived as metallic or bell-like. In this device, two audio signals are multiplied by each other, which means that the amplitude of the one sound is modulated by the amplitude of the other one. Sounds with strong transients are particularly well suited as modulators and more phonetic and constant sounds as carriers. Since a multiplication of two signals is executed and the order of the factors is therefore irrelevant, the functions, carrier and modulator, could theoretically be swapped. The sections are completely identical in their operation and function. The device does not react to MIDI notes, but is activated and deactivated exclusively via the on-off switch, whereby the selected ranges of the two samples are played in loops. Single samples can be loaded with the Add button. Using the Load button is very practical to directly load a group of samples that are located in a folder. The selection of a loop can also be done randomly. For this, the Random button must be pressed. The selection can be automated by pressing the corresponding Auto button. The desired loop length can be set separately. The time setting for the automated loading of the samples applies at the same time to the random selection of new loops. In the editor windows, individual loops can now be selected with a mouse. If required, it is also possible to zoom into the window. In the middle setting loop, the selected loop can be moved. Clicking and dragging up or down with the mouse changes the loop length. If you want to fix the length and not change it while moving, you additionally have to press the Shift key on the computer keyboard. Initially, the entire content is automatically selected for playback. If you want to go back to the total selection of the content after an individual selection, simply press the All button. Pressing the Norm button normalizes the sample content of the buffer. Note that this command does not affect the sample on the hard disk, but is irreversible with respect to the content of the buffer of the device. Also, the Crop command, which trims the respective loop selection to the appropriate size, is a destructive command with respect to the loaded sample. If the sample actually needs to be restored, it can simply be loaded again directly from the hard disk into the corresponding buffer via drag and drop. The buffer can be cleared by clicking on the X button. The shuffle and random functions of the upper and lower section of the Signal 1 module can be individually linked to the corresponding sections of the Signal 2 module. The playback speed of both samples and their respective module can be set individually. Here 1 means the original speed, 2 would be twice as fast and thus an octave higher, 0.5 half speed and an octave lower. Negative values mean that the samples are played backwards at the same speeds. If both loops have the same selected length and run asynchronously, for example after changing the speeds, this can be corrected by a quick click on the Sync button, which will make the loops have the same starting point again. The balance control reduces the amplitude of the opposite module in favor of the one on its own side, in order to make it more audible and provide it with less modulation. If you turn the knob to the left, signal 1 is less and less influenced by signal 2. until you finally hear only the original signal. If you turn the knob to the right, the same happens with signal 2. With the room knob you can add some reverb to the overall signal. Turning the low-pass filter knob to the left cuts the high frequencies of the signal. Furthermore, a wider panorama can be simulated by a delay time, which can be interesting especially on very centered samples or monosamples in general. When saving the Ableton Live session, it is important that the location of the sample that was last in the device is also added once in the so-called file preferences of Max, if the parent folder is not already part of the search path anyway, so that the file can be found again immediately by the device when it is opened again. If a new folder is added to the file preferences, it will be only recognized when the Max application is quit. Therefore, if a new search path is created, it is recommended to save your Ableton Live project only after this procedure to make sure that the edited sample remains in the project.